Welcome to the Storage Developer Conference sponsored by SNIA in EMEA 2021. I'm Howard Johnson, and today I'm going to talk to you about the introduction to fabric notifications from awareness to action. This is a new innovation in Fibre Channel, and I hope that you will enjoy what we have to talk about today. First of all, thank you for participating in the SNIA Storage Development Conference in EMEA, and we really appreciate the opportunity to share new technologies with all of our fans of the storage industry. In today's discussion, I plan on talking about fabric notifications, and particularly we'll cover the problem and the nature of the issue that we're trying to solve, and then we'll go through a series of steps that brought us to the solution, which is known as fabric notifications. Following that, we'll cover several use cases and give you an idea how it is that fabric notifications can be deployed in your environment. Then we'll wrap things up with a question and answer period. I realize this is a virtual event, so I've taken the liberty to write both the questions and the answers, but I hope you will find that they are informative, and these are also common questions that we've received when we've talked about fabric notifications for Fibre Channel solutions. So without further ado, let's go ahead and jump right in. Primarily, the problem that we're dealing with is the case of marginal links, often known as flaky paths, or even slow drain conditions or congestion. These are the kinds of things that occur intermittently. They're difficult to isolate because of that intermittent behavior. And that's fundamentally the problem that we went out and tried to solve utilizing fabric notifications. So let's take a look here at the basic issue. Over on the right-hand side of the screen, you can see that we have a small fabric setup with dual paths. And in this case, we have one particular path that is causing us some problems. If this path is a solid failure, it's very easy for both applications and administrators to be able to identify that particular path. It's easy to locate because the path isn't working. The devices themselves have identified that the path isn't working, and they probably sent up a notification to the administrator or logged that fact that in a place that the administrator can find. Those types of errors are quite easily resolved and mitigated. However, the problem that we find that plays a significant role in customer escalations is the problem where the issue occurs intermittently, but somewhat persistently. That is, it could be like a series of CRC errors that happen once every million frames, for example. But they're the kind of things that cause applications to end up going into retry. And they're also the kinds of things that cause multipath solutions a difficult time to locate and resolve. Congestion is also one of these types of problems. Typically, these issues are caused by marginal cables or SFPs or marginal connections, anything that has to do with the physical wire itself or components that are providing the connection. Or they can be due to congestion that has been the result of either lost credits, credit stall behavior, or oversubscription conditions. These kinds of oversubscription or congestion behaviors are often the result of organic growth within an environment. And typically, these issues occur at the least likely or likable points in time, and that is at the point when the activity in the fabric is highest, and these types of issues tend to surface and cause the most havoc in the system. And what we have found is that even with a multipath solution, these issues are difficult to isolate because the application detects the error and then attempts to do a health check using I/O. Oftentimes that I/O is able to succeed, and that path has still remained active as part of the overall solution. Utilizing a path that oscillates between active and health check status actually causes I/O to suffer for the entire system. What we found is that due to the serialization nature of storage, often in a dual path or multi-path solution, the one path that is causing problems of this nature can cause the entire solution to perform at an almost zero net performance level. That is, there's so much time being wasted trying to figure out what's going on with that one erroneous path that the other paths are underutilized. So why is it that this particular problem is now become much more significant in the fiber channel environments? Largely, what we're finding is that the solutions have become quite mature, quite diversified. That is, we have several different speed iterations that are available in fiber channel fabrics, and fabrics have become much, much larger. Furthermore, the solutions themselves have become much more sophisticated at being able to identify and notify administrators of these issues. The problem is that these particular tools have not been integrated in a standard fashion in order to be able to provide the end components with the ability to make better decisions about the issues that are occurring in the fabric. For example, an MPIO solution, if it knew that a particular path was suffering from physical errors, it could automatically kick in its alternative path selection techniques to identify other paths and move the workload away from that particular path with the physical error. Unfortunately, the MPIO solution is at a position in the stack that it doesn't have visibility to those physical errors. Fabric Notifications provides those types of applications with that visibility. And then lastly, what we're finding is that customers are becoming much, much more demanding toward automation. So rather than just having solutions that detect errors and then provide some type of a RAS log event or system log event that an administrator then has to decode, figure out where it's being generated, why it's being generated, and then spend time isolating the particular problem, wouldn't it be much better if the devices themselves could pinpoint that particular problem and mitigate that automatically? And this is what brought the fiber channel community to the Fabric Notifications solution. Conceptually, it's a collection of different types of notifications and signals that can be utilized to indicate when a particular link or path is having trouble. The notifications themselves provide a mechanism that allows the end devices and the fabric to report these events and send them to the registered devices. Furthermore, the payloads of those events include diagnostic information that identifies exactly what kind of event occurred, how often it occurred, and what threshold was triggered when the event occurred. These operations are implemented as extended link services in the fiber channel standard. The signaling mechanism is hardware-based detection capability that allows two ends of a link to be able to provide a bit of additional information about what's going on at the transmitter. That is, that the transmitter can provide a signal, a hardware-based signal, to the receiving side of the link to indicate that the resources on the transmitter are being consumed. That is, that there are a number of frames that are piling up at the transmitter that the receiver needs to be able to process in order for the fabric to operate in the most efficient way. Because these are done at a primitive level, these signals are most effective for credit stall conditions where frames are no longer able to be transmitted from one device to another. This diagnostic capability provides a level of notification between the transmitter and the receiver, indicating when the resources at the transmitter have reached critical levels, or at least a warning level. Again, the operation is implemented as a link level primitive signal to provide the ability to drill through, if you will, credit stall cases. What we found when utilizing Fabric Notifications in a multipath environment is that when a multipath driver detects that there is a particular error, rather than just realizing that the I/O didn't complete for some particular reason, a notification is sent by the end devices or the fabric that have detected what the physical error is all about. That notification is sent up to the HBA, and that's then further percolated up to the MPIO driver. Now that he knows that a particular path is suffering from an intermittent physical problem, he can make a better informed decision about what to do about the I/O going down that path. Since it's a physical error, he can simply say, I'm not going to use that path since I've got other usable paths, and he'll move the workload to the other active paths. If in some dire situation that the marginal path is the only path left, the MPIO driver can make the decision to go ahead and use that path in order to get some I/O across, even though occasionally errors will occur. So that provides a level of stability for the environment. Now, the MPIO solution sees when a physical error has occurred. It then moves the workload over to the active paths. If for any reason the active paths also become marginal, then you can still use the marginal paths to maintain as much performance as possible until the issues are resolved. Furthermore, the notifications provide data about exactly where in the path that the error has occurred, and that can be percolated up to the administrator logs for maintenance at a later point in time. What we found is that MPIO solutions that utilize fabric notifications have been able to deal with and mitigate automatically these types of intermittent issues. The flaky path issue, for example, goes away and performance is restored to near 100% capacity. So how did this all come about? So several years ago, back in late 2014, the fiber channel ecosystem began investigating this particular problem. As fabrics had become larger and escalations surrounding persistent intermittent issues had become much more prevalent, the industry found that it was exceedingly important for the fiber channel community to solve these types of problems. Interestingly, one of the things that we found was that only about 4% or so of all of the types of issues that occur in environments are associated with marginal paths or congestion. However, many of those issues end up being the majority of escalations at customer environments. So even though you have these small occurrences of these issues, when they do occur, they're pretty major events. Over the course of the next few years, the ecosystem came together and did a lot of research and experimentation on mechanisms and ways of detecting these issues, trying to figure out the nature of the issues, and then determining what kinds of solutions could be developed to resolve the issues. In late 2018, the community came together as part of the standards effort. And over the course of the last couple of years, have created modifications and additions to the existing fiber channel standards to support the fabric notification solution. In the framing and signaling standard, we've defined the congestion signal mechanism, and the link services standard, we've defined the notifications mechanism, and the switch fabric standard, we've defined the fabric detection and generation mechanism. So now let's take a moment and dig a little bit deeper into the standardization effort. First off, in the switch fabric standard is the description of how fabric notifications are detected and the signaling and notification is generated, as well as the registration mechanism. It also goes through and defines the scope of the detection mechanism and the level to which the standard defines how fiber channel devices will behave. The first thing to note is that registration is a key component of the fabric notifications mechanism. That is, only the devices that register to participate in fabric notifications will ever receive those notifications. This allows for the solution to be introduced into environments as new devices and drivers become available. The new devices or new drivers, once they're introduced into the environment, will register with the fabric and say, yes, I am ready to receive fabric notifications. But prior to that, those devices that do not register will not receive those those notifications. This is a key component to allow customers to be able to deploy this without having to do a rip and replace of their environment. That is, they don't have to upgrade every single component in the fabric in order to take advantage of fabric notifications. They can simply deploy it on a particular set of applications or servers or storage devices and gain an improved level of resiliency and performance in their environment. Furthermore, the Switch Fabric standard also includes an informative annex that provides notes and implementation references for vendors who want to develop fabric notification solutions. In the framing and signaling standard, we've gone about and defined the primitive necessary to generate the congestion signal, as well as defining a new timeout value known as the frame discard timeout value that provides end devices with a threshold for determining when frames can no longer be moved through the fabric in order to achieve the resource allocation timeout requirements of Fibre Channel. This new timeout value provides both the fabric and the end devices with the ability to exchange this information and then utilize it to indicate when a frame can no longer be processed. The congestion signaling mechanism provides two different types of signals. One is a warning signal, and the other is an alarm signal that provides the transmitter with mechanisms to be able to set particular thresholds to indicate how severe the congestion problem or the credit stall problem is. In the link services specification, we go through and we define all of the necessary components to support the fabric notifications functionality. That is, there's an exchange diagnostic capabilities extended link service that allows end devices, that is two devices on each side of the device on each side of the link, to exchange information about their diagnostic capability. It is this particular ELS exchange that allows the congestion signal capabilities to be exchanged between a transmitter and a receiver. There's also the register diagnostics functionality ELS that provides the mechanisms we've mentioned before, an end device to indicate that it wants to receive fabric notifications. So that particular payload indicates to the fabric, hey, I want to listen for the fabric performance impact notification event, and I only want to listen for particular types of FPIN notifications. So it allows the implementations to completely control exactly what level of participation that they want and the degree to that level of participation. Furthermore, there's an informative annex in this particular standard that provides, again, more examples as well as information about how to go about implementing various characteristics of the fabric notification solution. Now let's just summarize what we have so far. So fabric notifications consists of a congestion signal mechanism, which is a primitive that is sent from the transmitter to the receiver to indicate that there's resource depletion at the transmitter. That is, that frames are backing up at the transmitter and the receiver needs to take some type of an action to accept those frames that are destined to the receiving device. Secondly, there are notifications, ELSs, that are used to, one, exchange the diagnostic capabilities between endpoints of a link, two, register their participation in the fabric notifications functionality, three, to notify the registered participants of particular events that are causing fabric performance impacts, whether it's a link integrity event, such as a marginal physical layer type of issue on a marginal link, a congestion notification where a local port is congested due to, say, read oversubscription, for example. A peer congestion notification, which is utilized to indicate that there is downstream congestion, write oversubscription, if you will. And a delivery notification that indicates when a frame has been, a command frame, for example, has been discarded in the fabric or an end device due to the inability to move that frame through the fabric for whatever reason. This provides us with the foundation to be able to support fabric notifications in Fibre Channel solutions. In our next segment, I'm going to talk about the use cases. So at this point in time, I'm going to pause our recording, and then we will move on to the use cases and questions and answer into the next session.